Let's start with the comparison of acidic character of alcohols and phenols. But before that, I just want to recapitulate few important things. What are these? One is that acid is acid because of furnishing of hydrogen ion. So acid, what is the property of acid? That furnishes hydrogen ion. Furnishes hydrogen ion. Easier is the furnishing of hydrogen ion. Stronger is the acid. And furnishing of hydrogen ion in turn depends on polarity of oxygen hydrogen bond. Let me tell you here, greater is the polarity. Greater is OH bond polarity. Weaker bond and easier is furnishing of hydrogen ion release, or you can say hydrogen ion will be released more easily. So that's how we can consider the first criteria which we discussed in the previous class, that furnishing of hydrogen ion is one of the criteria for an acid to be a stronger acid or a weaker acid. Now the second criteria was that after release of hydrogen ion, the conjugate base formed should be strong. So that is another criteria. So that should be stabilized. Basically, that should be stabilized, not strong, that should be stabilized. So if the conjugate base is stable, it means the acid has to be strong acid. So that's how we can discuss. But before that, I just want to draw your attention regarding the comparison of the acidic character of water and alcohol. In alcohol and water, alcohol is acidic in nature, that we have observed because it reacts with an active metal to liberate hydrogen gas. So that is why it shows the acidic properties. But it is a weaker acid even than water, is indicated by the reaction where this conjugate base of alcohol is accepting a proton from water, or you can say water becomes a proton donor. So that's how water is a stronger acid. Now how can we explain that water is a stronger acid? That can be explained on the basis of the greater polarity of oxygen hydrogen bond, because in case of water, oxygen hydrogen bond is more polar. More polar means the bond is weaker. Why the bond is more polar? Because no electron releasing group is present. While if we see the alcohol, in case of alcohol, there is minimum one alkyl group has to be present, and this alkyl group has electron releasing nature. It will increase electron density on this oxygen, and that's how it will make oxygen hydrogen bond less polar. That is why the bond will be stronger. Stronger means hydrogen ion will be released with a difficulty. So this is all about the comparison of the acidic character of alcohol and water. Now we are starting with the next topic, that is comparison of acidic character of alcohol and phenol. We observe this very well, that alcohol as well as phenol, both, they react with sodium metal, they react with the active metal to liberate hydrogen gas. This is one of the property which shows that they are acidic in nature. But other property, that is ROH on reaction with a base, alcohol on reaction with a base is not reacting at all, no reaction. While if we do the same with phenol, that is phenol on reaction with sodium hydroxide, it will liberate, or it will give salt and water. Which salt will be obtained? It is sodium phenoxide plus water. So both these reactions show that phenol is a stronger acid than alcohol, because alcohol give only one characteristic, or is showing only one characteristic of the acid, while phenol, that shows both. One more thing I want to tell here, that alcohol as well as phenol, both of them, they will not turn blue litmus red. So they are acids, but they are weaker acids. But still, phenol is a stronger acid as than alcohol. So how do we explain it? How phenol is a stronger acid than alcohol? Let's do it. We can explain it through resonance. Resonance we have done in class 11 also. This is the structure of phenol. This is the structure of phenol. Now here this is sp2 hybridized carbon. That is why it will withdraw this pair of electron towards itself. In turn, this will be shifted here. So what will be the next resonating structure? Next resonating structure will be something like this. Oxygen left with one lone pair only with a positive charge. This pair of electron, this lone pair shifted here as a pi bond, and this pair is shifted as a lone pair. Now this is again sp2 hybridized carbon, so it will withdraw this pair of electron here and this will become here. So what is the next resonating structure? Next resonating structure is like this. Double bond OH, one lone pair, positive charge. Here is the lone pair, and this lone pair is making a pi bond here. Now this is withdrawn by this sp2 hybridized carbon. This will become a lone pair. So what is the next resonating structure? The next resonating structure will be something like this. Here is a double bond, one lone pair, positive charge H. Here is the lone pair, here is the pi bond. Now this sp2 hybridized carbon will withdraw this pair of electron towards itself, and in turn this will be shifted here. So what will be the next structure? Next structure will be something like this. O with two lone pairs again. So here what do I want to show, or what do I want to tell? That in structure, if we number these structures as A, B, C, D, E. In structure B, C and D, we can see oxygen is carrying a positive charge. Oxygen is carrying a positive charge. What does it mean? Its tendency to withdraw this pair of electron towards itself is more, and that is why hydrogen ion can be released more easily. I hope we understand it. The positively charged oxygen will become more electronegative, or you can say it will be having greater tendency to withdraw the pair of electron. That is why it will tend to withdraw the shared pair of electron towards itself more strongly as compared to alcohol, and that is why hydrogen ion will be furnished more easily. So that's how it is. So what do we say here? That oxygen in structure B, C, D, oxygen carrying positive charge. Oxygen carries positive charge, which will increase its electron withdrawing tendency, or you may say will increase the polarity of oxygen hydrogen bond. Increase polarity of oxygen hydrogen bond, and that is why oxygen hydrogen bond becomes weaker and hydrogen ion is furnished more easily as than alcohol. Now the second criteria for the acidic character comparison, that is the conjugate base form should be stable. Now let's compare this, that in case of alcohol, this is an alcohol, that is ROH, that dissociate to give RO plus H ion. RO, that is alkoxide ion. This is the conjugate base formed by the dissociation of alcohol by furnishing of hydrogen ion. So this is the conjugate base. So this should be stable. So this is okay, this is stable. But what about phenol? Phenol on dissociation gives this phenoxide ion. Now this phenoxide ion is more stable as compared to alkoxide ion. How is it? How phenoxide ion is more stable? Let's do the resonance in case of phenoxide ion. This is the structure of phenoxide ion, that is benzene ring with oxygen with 3 lone pairs and a negative charge. So this is phenoxide ion. Now this phenol in here, this carbon is sp2 hybridized. So this will withdraw this pair of electron towards itself. In turn, this pi pair of electron will be shifted here as lone pair. So what it will become? This is becoming a double bond only 2 lone pairs are left on this oxygen now, and this pi pair became a lone pair. Now this is sp2 hybridized carbon. It will withdraw this pair of electron towards itself, and this pi bond is shifted here as lone pair. So this become a pi bond here, this become a pi bond here, and this is the lone pair here. Now this sp2 hybridized carbon will withdraw this pair of electron towards itself, and that's how this will become the lone pair. And this is the next resonating structures. And now this is the next resonating structure. Then this sp2 hybridized carbon will withdraw this lone pair towards itself, and this pi pair will again become a lone pair. So this is the next this is the next phenoxide ion structure. So here we should see that oxygen is here we should see that phenoxide ion is stabilized by resonance. That is why it is more stable as compared to alkoxide ion. There is another reason for phenol to be a stronger acid. What is the other reason? That phenoxide ion formed is more stable even than phenol. How is it? Because phenoxide ion, there is no charge separation, while in case of phenol there is charge separation also. You should observe it. You should recall class 11 part. There we studied that if any resonating structure is involving the charge separation, will decrease the stability. So here you should observe that positive here, negative here. So the charge separation is making phenol less stable as compared to phenoxide ion, and when this is more stable, definitely the tendency for its formation is also more as compared to phenol. So phenol tends to convert easily into the phenoxide ion. So that's how we can say that phenol is a stronger acid as compared to alcohol. How is it? Number one, I am just trying to recapitulate everything. Number one, alcohol is a stronger acid, phenol is a stronger acid than alcohol because it can easily furnish hydrogen ion. Why it can easily furnish hydrogen ion? Because here oxygen carries a positive charge on it because of the presence of this benzene ring, or you can say because of the resonance happening here. So this positive charge on oxygen making this oxygen more electronegative, or you can say this is making this oxygen hydrogen bond more polar. More polar means weaker. Weaker means hydrogen ion is furnished easily. So this is one thing. The second is that phenoxide ion is more stabilized because of resonance, while in alkoxide ion there is no resonance. That is why it is phenol is a stronger acid. This is all about the two criteria which we discussed. Now the third thing I am talking about, the stronger acidic nature of phenol than alcohol is because phenol is lesser stable as compared to phenoxide ion because it involves charge separation, while in case of phenoxide ion there is no charge separation, which makes it more stable. So that is why, or that is how we can say phenol is a stronger acid than alcohol. Now the next thing is, what is the effect of substituents on the acidic strength of phenol? Let's discuss about it. Say for example, this is phenol. Having an electron withdrawing group. Say the electron withdrawing group, that is nitro group, is present here, NO2 group. So NO2 group, what is the nature of electron withdrawing group? What is the nature of nitro group? It is electron withdrawing. So this will withdraw electron towards itself. It will be having minus I effect. So it will withdraw electron towards itself. So this carbon become electron deficient. In turn, it will withdraw electron from here, etc., etc. And that is how oxygen become more electronegative. And that is why it will make this oxygen hydrogen bond polar, or you can say will increase the polarity of oxygen hydrogen bond. That's how it will increase the acidic strength also. Now what about if the nitro group is present at ortho, para and meta position? So let me tell you, because nitro is a meta directing group, that is why its effect is maximum when it is present at meta position. So meta nitrophenol will be the strongest acid, followed by ortho, then para. So that's how it is. Orthonitrophenol, paranitrophenol, what is the order of their acidic strength? Order of their acidic strength is paranitrophenol is most acidic, followed by ortho, followed by meta. Meta will be having minimum effect. meta will be having minimum effect. It will be having maximum effect when it is present at para position. Now what about an electron releasing group? Say for example, if a methyl group is present, at ortho position, or you can say if methyl group is present anywhere, it will decrease the acidic strength. Why it will decrease the acidic strength? Because of the plus I effect. It will decrease the polarity of oxygen hydrogen bond. That is why it will decrease the acidic strength. So if we try to arrange them in an order, we can say cresol. It may be ortho, para or anything. Cresol is a weaker acid than phenol, while nitrophenol is a stronger acid. The position we will discuss afterwards, but I'm just trying to tell you that the nature of the substituent, electron releasing will decrease the acidic strength, while electron withdrawing will increase the acidic strength. So that's all about the acidic strength of alcohol and phenol. Effect of substituent and the pKa value, all we will discuss in the next lecture. Thank you.